Sustainable farming practices are the key to promoting soil health to ensure soil fertility and food production for future generations. My name is Alberto Acedo, the Chief Scientific Officer at Biomakers, and because health only applies to living things, my colleagues and I aim to use soil microbiome to assess the functional status of the soil and to keep searching for universal soil health indicators. To demonstrate the informative potential of soil microbiome, here we use vineyards as crop models, analyzing 350 vineyards across two countries, US and Spain. And because farming intensification can be linked with soil health status, all vineyards were classified depending on their management in conventional, organic, and biodynamic systems. Soil samples were collected and soil microbiome was analyzed using ITS metabarcoding next generation sequencing workflow. In order to explore microbial communities through different prisms, we applied a network-based approach similar to the social media analysis, but as applied to the soil microbiome, we analyzed co-occurrence and co-exclusion patterns in all taxa detected in all samples analyzed to build a network, also called MetaWeb, where each node represents a microbial taxon and each connecting them representing a statistically significant co-occurrence or co-exclusions. Learning from the co-occurrence patterns in the MetaWeb model, we then describe the structure of individual samples by considering those taxa detected in the local communities and analyzing their network properties. As a result, with independent location, the fungal communities in Vineyard Soils showed a clear difference in their network properties depending on the farming practices applied. Conventionally management soils clearly give rise to low clustering, high modular fungal networks with higher proportion of co-exclusions compared with the opposite result found in biodynamic management vineyards, that we close to the concept of small wall networks. These patterns can be explained because the intensive fertilization and pesticides programs applied in conventional farming can produce a metabolic selection of species in a high competitive and specialized habitat, in contrast to less intensive management that generates a more generalist-based habitat in biodynamic systems. Our data support the idea that emergent network properties of soil microbiome can be used to assess the soil health and can provide new evidence for future demonstration of the diversity and stability hypothesis, and also monitor how the implementation of new farming systems as regenerative agriculture may lead the sustainable goal of agroecosystems.